That is exactly right. That is how he defined purebred. Generation after generation, if you keep mating the plant with itself, it'll never produce anything else. A tall plant mate with itself, it'll produce a tall plant all the time. That's true for this original tall plant, yeah.
He said that two plants that have the same genes, if they're bred together, then basically the same type. Of the same type, so.
Well, remember, Mendel knew nothing about genes. Okay. So right now, we are back in Mendel's time. We don't know anything about genes. We're just talking of some traits, some characters, right? Some characteristic of the plant. And what Shobhadra said was absolutely right. A purebred, the way you know a purebred is, you take this and you keep mating it with itself, it'll always produce exactly the same kind. As opposed to these other tall plants that you got, which look tall, they look identical to the original, but they are not like the original, because if you mate them with themselves, they behave differently. They give 3/4 like tall and 1/4 short, right? So that's what a purebred is. So now you can have a purebred for height, and you can also have purebred for roundness, right? And you can have them in the same plant. You can have a tall plant with round peas, and you mate it with itself, you'll always get a tall plant with round peas. You can have a short plant with wrinkled peas, you mate it with itself, and then you get short plants with wrinkled peas. That's clear, right? So those are like two characteristics. Plant can have many other characteristics. He only happened to study a few of them. So now tell me how you'll devise an experiment to prove that these two characteristics have nothing to do with each other. Am I losing you?
So, you take maybe a tall plant with
Speak
round
louder.
peas that's purebred, and then you take another tall plant with round peas that's maybe not purebred,
Okay.
and then you breed them, and you probably won't. You might not get a tall plant with, like, you might get a tall plant
Okay,
with
that's a
wrinkled
good guess.
peas.
That's a good guess, but we also need to bring in the wrinkled peas, right? Otherwise, how will you do your experiment? Shriya,
I was thinking it might need like 4 plants.
4 plants? Yeah. So tell me your experiment.
So 2 of them will be what do you call it? Purebred, the tall ones, with the, because there are 4 and 2 characteristics we're dealing with, which is the height and the type of pea. Since there can be 2 types of peas and 2 types of heights, so that means like tall and short and wrinkled and not wrinkled. So if you match them up, each one after another, so you'll have like way more patterns to look out for. So if you do it with 4 plants, you can easily see the patterns of how they're breeding if you have 4, because these are 2 of the characteristics.
I agree with you that you could do your experiment with 4 plants, but I think at the end you'll have some difficulty in analyzing and understanding your results. So okay, let me tell you what Mendel did. Mendel took a tall plant with round peas and a short plant with wrinkled peas. Purebred, both of them are purebred. And now, just following these rules, can you guess what would happen?
Tall plant with wrinkled peas, tall plant with round peas, short plant with wrinkled peas, and short plant with round peas.
Okay, very good. So, let's do this now. I'm going to erase the trees and I'm going to start with the notation. So, he introduced a notation and I'll come to that later. Okay, that's not. So, there's a tall plant and you remember that in the original, the purebred has 2 copies of this, right? That was his theory, that you have 2 copies and one copy gets, during the mating process, you pick one of this and one of the other, right? So now this is a plant with 2 characteristics, right? So what should this look like? TT is for tall, and then round, what would the roundness look like? Yeah? Who was saying R? Yeah?
R, T, and R.
TT is for the tallness.
RR.
What would be for roundness?
RR.
RR. Excellent. RR. And now this other guy, he's what? Short plant,
SS.
short
SS.
plant,
SS.
and then
WW.
WW. And then what would happen during the mating process? Huh? What are the different combinations possible? So, what is the law that Mendel basically said? When you have these 2, this is for tallness, one of them will go out. This is for roundness, one of them will go out. This is for shortness. So let's say in one mating, you could have a tall from here, a round from here, a short from here, and a wrinkled from here. Remember, we are talking of 2 traits, right? 2 traits means what? 2 traits means each trait has 2 copies in the individual. So 2 traits will have 4 copies. So after the mating, you get a T from here, a R from here, a S from here, and a W from here. That is one possible combination. Is that clear? You guys get it, right? So, what are the other combinations possible? And remember, there are every product will have to have four individual letters in them, right? Because sorry, I didn't get you. Sorry.
TWSR.
Okay. T. Well, no. Okay. So you either choose this T or this T, this R or this R, this S or this S, this W or this W.
We could use 2 colors for T, then it's probably easier.
Okay.
Then we know which T we are taking and
Good
which R.
suggestion. Let me use 2 colors. These are like
Yeah.
2 copies of T and 2 copies of R. By the way, they are identical. Yeah.
Do you think I could maybe blow this up because it's kind of hard?
You can't see, or if, do you want, okay.
Or
We'll need this, but I
Oh, you
think
want me
he's-
to do it on the other side, right?
No.
raise that
For
Yeah.
now, we could raise it, and then when he's going to turn on, yeah, it should be. Then we can move.
Thank you.
Yeah, you should have told us.
Oh, this is not good. Stop. So let me do it on this side because I think that center.
Just a second, I need to move the camera.
You have a
Thanks.
T and a T, and a R and a R, and sorry, I have to color code this. So this is one copy, this is another copy, and then you have a S and a W. So S and S and W and W, right? So what are the possibilities that you have? Yeah. So out of this, the rule is very simple. During the mating process, for every trait, you take out of the two identical copies, in this case they are identical, you randomly choose one. And from the other parent, you again randomly choose one of the same trait. And then you put them together, right? Everybody gets that? So you will take T from here and S from here, right? That's one combination. Then you can take T from here, S from here, T from here. Now the T and the S go together, right? Because they are for the same trait. Now this was what Mendel's theory was, that the trait for tallness is not completely independent of the trait for roundness of the piece. So if that were to be true, then what would have happened? This round would mate with this or with this. So what are the possible combinations you'll get? You'll have a T with a S like this, black S, this copy. A T with the small s, R, wait, we'll go to the R later. So for the height of the plant, you got these, right? Now you need the other two. So what would you do? So TS, let me draw the TS here a little bit spaced. TS, TS, and then for this, what would you do? You would have a R with either this S or a R with the small s. That's another combination. So this is one combination, this is another combination. Yes, Shreya.
Could you clarify the second one for?
You do the S or W?
Oh, sorry. TS, this will be RW. Yes, you are
So you've
absolutely
already
right.
used the other, yeah.
Yes. Good catch. Does it make sense? And so you can draw all these combinations. And how many combinations do you think will come in total? And this is really, you should just be able to tell it from common sense. Yeah?
16.
Why? Why 16?
4 times 4.
That's good. So the other way of looking at it is here. Okay. 4 times 4, essentially, that's what it is. So you can choose something here, like the first letter here, it's going to come from this pair, right? So you can choose it in two ways. It so happens that this pair is, actually I'll use a different color so that they don't get confused. You can choose this in two ways. 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 And where does the independence come from? The independence comes from the fact that the way you choose this has no effect on the way you choose this. If you can choose this in two ways, you can also choose this in two ways. Is that clear? Okay. So, as Srijan said, there are 16 combinations. Are all the combinations unique? No. So what are the unique combinations we'll get here? You understand what I mean by unique combinations, right? I mean, this is not a unique combination. Even though there are different combinations, like there is a color here, but it's still the same at the end of the day, right? So what are the different unique combinations you can get?
There's 8
8? Why 8?
because since there's 16 non-unique combinations,
Right.
you divide that by 2 factorial because 2.
It's 2.
Yeah, it's 2, right? And you get 8.
You get 8. Let's do it. So, what are the things you can get? You can get TT or R. That's one combination. T S or R. ST is same as TS, right? The order in which you put these letters doesn't matter. So that doesn't count. And then here, what do you have? You can have R, W and WW, right? So you can have RR, RW, WW. You can have TS, TT, TS and SS. Right? So 3 combinations arising out of the tallness, out of the height, and then 3 other arising out of and round. And then how many ways are there to put these together? So you can take this and either use this or this or this. It will be a different combination,
9.
right? That's
9.
3,
9. 9.
right?
9 is the 9 is the
Now do you get it?
Yeah.
yeah.
So there are 9 combinations. Okay? So 9 different combinations. Do you think each of them are equally likely? Like, so we can write down these 9 combinations, right? This with this, this with this, and this with this, right? They are independent. Are they all equally likely?
No. You mean physically? Physically.
Now, first,
hybrid that's formed will be the same, right? So you
That
probably
is
need
true,
to
actually.
skip that one step, so maybe
Actually, that's
confusing.
true, that's true.
But then you go to the second step.
Then that's
where you
easier.
show all the
That
probabilities.
is true, that is
I
true.
think that's what some of the confusion is coming.
Yes, okay. Yeah, I skipped a generation because I
Yeah,
kind of,
I think it would be nice if we do that generation.
let's do that generation.
You can erase this part, the left part.
Thanks. Yeah. So in the first generation, what would you have? Go to your original what we did. What do you have in the first generation? First generation, remember we did this, just the T's and just the S's. Purebred, tall and short. First generation, what will you have? Yeah.
TRSW.
No, forget the roundness. Let's just repeat what we did for the.
TS.
TS.
So one
No.
trait.
TS.
TS.
Tall and short.
So you'd get a TS, and what else would you get?
TT.
Did you get a TT?
Because the
What did we do? Remember?
Tall and short.
Because remember, there is one tall and one short, purebred. One guy has to come, like one has to come from this side, one has to come from this side. So everything has to be TS, right? So everything is TS here, and everything is what?
RW.
RW.